So for this homework, we're going to be graphing derivatives. So if you look at this function here, you'll see that this point right here is the origin. And so we just have a linear function that goes with a negative constant slope. And the slope of that, we can just look quite easily, is from here to here, a change of over 1 down 2. So our slope is negative 2. Therefore, if we graph the derivative, we are just graphing a line that is a horizontal line at the negative 2. So this right here is our, we'll say, f prime of x. We could also say y prime of x. Either one is fine. Now for number 3, we have a slightly different situation because we have a parabola. So one thing we know for sure is that the derivative is 0 right here, because the sketch of a tangent line says that the slope right there is 0. So then we have the situation where it's negative on the right-hand side of this and positive on the left-hand side of this. So that means we have a line that is going down. So the question is, what is that slope? Well, if I look, this is actually very obviously a function of y equals x squared. It's just moved. So if this is my origin, I have moved it up 3 and over 1. So it's not y equals x squared, it's y equals x minus 1 squared plus 3. So I could go through all of the pain of dealing with all of these numbers, or I could just think about how this reflects from y equals, this is negative, y equals negative x squared. So here I know that at 1, right, I can sketch a little tangent line, and that tangent line appears to have a slope of approximately 1. Then again, I can look down here, and I have a slope that is approximately negative 4, I believe. So what that means is I can look and just sketch a very simple derivative with those points in mind. That is just a line that has a slope of negative 1. So this right here is my y prime of x. For question 4, however, we have something that looks like it is a cubic function. And hopefully we recognize cubic functions. This one, so we'll have something that is like x cubed. And so when we go in and we look at this, we look at a bunch of different points in the tangent lines. So for instance, right here, we would have a tangent line that is horizontal, and here we would have a tangent line that's horizontal. So if we plot y prime of x, at those 2 points, the value for y prime should be 0. So we'll start with those 2 points. Then we look at the slope or the value between those 2. So for instance, between these 2, we have a slope that is negative. So we would have y prime is less than 0 for those between those 2 points. Then on the left side of this point, we have a slope that is positive. It's increasing from left to right. So y prime is greater than 0. Then from here and onward, we also have a situation where the slope is positive. So what does that mean? That means that the value for y prime has to be negative, so less than 0, between these 2 points. So we should have something that looks like this, because it starts at 0, and then it decreases, and it's most negative right here in the middle, and then it goes back to 0. Then we have something that is positive, and it's decreasing down to 0. So what we end up with is something that looks like a parabola over these points. So my y prime is a parabola, which is great because we said that the function y, the blue part, is cubic, so our y prime of x is something similar to x squared. So for question number 8, we're given a table of values, and we want to find the approximate value for the derivative of f at each of the x values that is given. So in order to approximate this, we really have a couple different possibilities. So first, I'm going to start a new row here, which is f prime of x. So what I have is a situation where f of x is changing at each one of these instants. And the only information I have to go off of are these different values of y. So I really could do this 2 different ways. I could, if I wanted to, plot these points in my calculator and then do regression analysis to figure out an equation for f of x, and that would give me a value for f prime of x. Or what I could do is simply take a look at these points, the adjacent points, and find the average rate of change between these 2 points, or between points on either side. So for instance, if we remember that average rate of change is going to be f of x2 minus f of x1 over x2 minus x1, then for my first point, I'm going to have an average rate of change somewhere close to -5. And that's just from saying 13 minus 18 over 1. For the next, this is -5 and this is -3. So my instantaneous rate of change, my f prime, is probably close to -4. From 2 to 3, I decrease by 1, and from 1 to 2, I decrease by 3. So it's somewhere between 1 and 3. So a good estimate would be -2. From 2 to 3, we go down by 1. From 3 to 4, we don't change. So it's probably somewhere between those two. So maybe 0.5. So remember, these are just approximations. Then for the next part, same deal. We don't change here. We go up by 2 there. So let's say +1. Then we have up 2 versus up 4, so possibly up 3. And then we have up 6 versus up 4, so this would probably be up 5. And then we have up 9 versus up 6, so this is somewhere in between those two, which we might say is about 7.5. And then here we just have up 9, so the best we can do is approximately up 9. So the question that follows this up is, where is the rate of change positive? So the rate of change is positive somewhere to the values greater than x. So this would be the case where f prime of x is greater than 0. That's when it's positive. To the left of this, you would have a situation where f prime of x is negative. That's when the slope is negative. So we want to know, where is the rate of change the greatest? Well, it seems like it's greatest at 8, right? This right here is my greatest rate of change, period. Right? Regardless of if we're talking about increase or decrease. And so that simply just comes from the fact that it seems that the rate of change of, the value of f of x is changing most rapidly once you get to the 7 or 8x mark. For question number 10, we have A, B, C, and D parts. And we have 6 choices in x values at which to match to these. So the first part, A, says when is f of x the greatest? So our graph, we will double check here. This blue line represents f of x. So we want to know when the value for f of x is the greatest. So out of all of these, we have a point here, a point here, here. So this is 4, 5, and 6. So at which of these is f of x the greatest? Well, that would be at x3, because this right here is literally the greatest value for f of x. For B, we want to know when is f of x the least. So out of all of these, the actual value for f of x that's the lowest is between x1 and 4, and it appears that x4 has the least value for f of x. Now C is where it gets interesting. So C asks, when is f prime of x the greatest? So this is when we want to start looking at tangent lines. So if I sketch a tangent line, we'll do red here. At x1, we have something that looks like this. x2, x3, x4, x5. Ooh, that could be better. And x6. And we want to know, when is f prime of x the greatest? So this is very positive. This is slightly less positive. This is negative. This is pretty positive. This is pretty positive. And this is pretty much 0. So if we look at these, I see that really between x5 and x1, you have a very steep slope. In fact, I would say that x5 is the steepest part of the line. So it would stand to reason then that the derivative at x5 is the greatest. For d, if we're looking at the derivative when it is the least, well, the only derivative we have that is negative appears to be at x3. So that would be our least value for f prime of x. Questions 11 through 13 are actually asking us to sketch f prime of x. And the only stipulation is that they are consistent with features on our f of x graph. So f of x here appears to have a solid negative slope the entire time. The slope for this we could just actually calculate, but we don't really have 100% of the values. So in fact, this one we can calculate because we know that you end up at 2, 0. So this, so 2, 0 versus 0, 3. And so my slope is going to be 0 minus 3 over 2 minus 0, or just negative 1.5. So since the slope is constant, that means my f prime of x is constant. So really, f prime of x is just equal to negative 1.5. So if I were to graph this, that would just be a line that is horizontal at negative 1.5. So this is my f prime of x. For number 12, we have the same situation. We can calculate the slope for this function. And our slope is going to be equal to f prime of x. So our slope, we end up at 1, 0, and we started at 0, 2. So our slope is going to be 0 minus 2 over 1 minus 0, or just negative 2. Therefore, my f prime of x is just going to be equal to negative 2. So I will plot that as just a straight horizontal line at negative 2. Number 14 is a little trickier because this is a parabola. Now we don't have a lot of information here. We don't have any of the y values, but we can go ahead and sketch this very easily. At the 1x mark, we have a slope of 0. The tangent line would just be horizontal. So at the 1 mark, my derivative is going to cross the x-axis. Now the question is, what happens on either side of this? On the left-hand side, we have a slope that is positive. So f prime of x is greater than 0. On the right-hand side, we have a negative slope. It's decreasing. So f prime of x is less than 0. So all I need to do now is sketch a line that is positive on the left-hand side and negative on the right-hand side. So I can sketch a line that just looks something like this. And that's the best I can do because I don't have any more values. So questions 21 and 24, you're given f of x, and you're asked to match it with some f prime of x down below. So what we're going to do is we're going to just look at the values of the slope as we go through this function. So for instance, we'll just draw above it actually. So at this mark right here, we have a distinction. This is right where our slope is 0. So if my f prime is this, so my slope is 0 at that point, and it's also 0 at this point. Now the question is, what happens in between it? So the slope in between it is positive, right? You are increasing the value of the function. To the left-hand side of this, we have a negative slope, and to the right-hand side of this 0, we also have a negative slope. So we want to find a graph that is negative on the left end. It goes through 0 to be positive, and then is negative on the right end. So out of these, which follow that? So number 1 does not, because it is negative up until this point, then it is positive, then negative, then positive again. So positive, try this again. Negative, positive, negative, positive. And so we're looking at the values of this now. Here, my f prime of x is positive up until this point and then negative below it. Here, my f prime is positive, then it's negative for this section, and then positive again. So this could be our answer for 21, but we'll keep going. Here, it's all negative. Here, it's positive the entire time. Here it is positive and then negative. Here we have positive, then negative. And then here we have negative, positive, negative. So out of all of these, it appears that Roman numeral 3 is the correct graph of f prime. So again, what we're doing here is I'm looking at the slope of f of x, and I'm saying that for the first section, the slope is negative, which means that f prime of x has to be negative for that section. And so if I look at this graph, f prime of x, oh, I did this backwards. I'm so sorry. It's not 3. It would be this other one. It would be 8. Because the f prime of x is negative up to a point, then it's positive in the center, and then negative again. So 24, we have a situation where our slope is positive up to this point. So this is f prime. Then our slope is negative for some section, and it gets closer to 0. Right? This slope all the way over here is 0. So it would be 0 somewhere there. So it's getting closer to 0 as it goes to the right. So which of these is the best? Well, it has to start positive on the left-hand side, and then it turns negative, and then it gets close to 0. So it appears that 6 is the graph for the derivative of number 24. So for this, I've gone ahead and sketched a set of axes, and I'm going to try and sketch my f of x given information about my f prime of x, which is my derivative. So just keep in mind that derivative basically means slope. So the first part I'll start with is the slope, or the derivative, is 0 at x equals negative 1. So that means that all this has to be is horizontal. There needs to be a horizontal tangent line at x equals negative 1. So I'll just sketch a little horizontal tangent line for a second. At at x values below this, my slope has to be positive. So that means that I'm going to go up to this. So I have to have a slope that is going up. Then for x is greater than negative 1, my slope has to be negative. That means after x equals negative 1, I have to be negative. So putting all of this together, I need to sketch something that just has to be increasing up to negative 1, then it goes horizontal, and then it is negative for the remainder. So you could draw this. You could draw something where you have an increase, and then you do this, and then it's just a very slight decrease. The important part is that the slope is 0 at x equals negative 1, that it's positive to the left, and then negative to the right of that mark. So any of these are possible. So positive slope to the left, negative slope to the right. Any variation of that will work.